Hello friends, in this video we will see the top 10 interview questions asked in Apple interviews. So let's see the first problem. So it's two-sum problem. So in this you are given a list of numbers and then you are given a target and you have to pick two numbers which add up to this target. And this is very popular and I would have covered it in other top 10 videos. So in this case you can see that 2 and 11, if you add them you get 13, so you have to return the indices start and end. And in this approach if you apply the brute force in this problem, you will get in O of n square because you pick the first number, you try to find target minus 2, that is 11. This may not be part of the solution, so you may end up doing it for many of such numbers and you may end up trying to find n minus 1 plus n minus 2, so that sum will apply and you will get O of n square. But in the optimized case you should use a hash set or a hash map, so that whenever you visit any number you store that in the hash map. So first time you visit 2, you look for 11 in the hash map, the remaining number, you don't find it and you store 2 in the hash map with the index 0. Then you go to 7, you look for the remaining one, that is 6, you don't find it, so you store. So 2 is stored at index 0, then 7 is stored at index 1. When you reach here at 11, you look for 2 because the remaining number is 2, 11, and the remaining is target minus 11. So you look in the map, then you find 2 at index 0, so you return 0 and the current index, that is 2. So in this way you will reduce the time complexity to O of n, but you will have a space complexity of O of n as well due to the hash map. Now let's see the next problem. It's called LRU Cache, and again this is a very popular design problem where it has been asked multiple times in I think Microsoft interviews as well, so I would have covered it there in that video. So here you have to design an LRU Cache class. So that will take some default capacity. Cache is not unlimited, it will have some capacity and you will need some policy to remove the keys once the cache is full. And here you would like to implement two additional methods, put and get, where get you would like to fetch the value corresponding to a given key if present in the cache. So this should work in O of 1, and if not present it will add that to the cache. And then you have put method where you can put a key value pair in the cache. And LRU means least recently used, so you should have your eviction policy in such a way that the keys that are used very recently should be the one in the queue, and when you have to evict some key from the cache, then you will remove the ones which have not been used for quite a long time. And this is lead code problem number 146. The previous one was lead code problem number 1. Now let's see the third problem. It's called spiral matrix, and you can find the details in lead code problem number 54. So let me go through it once. So you have to print the elements of m cross n matrix in spiral fashion. So there are m rows and n columns. So you start from top left and go to the right. So you visit like this. Then when you reach the end, you come down, you change the direction. When you again reach the bottom, you go left and again go top, but not to the top row, till the second row. Top row is already visited. Then again turn right and then you stop before the second last row. So this process is repeated until all the elements are printed. So you see what is the approach. So you will start from 0 0. So you can have a few variables like top, bottom. So top will be initially 0, bottom will be initially m minus 1, left will be 0, right will be n minus 1, the last column. So initially that is the state, and you keep the row constant. So it will have some name, this matrix, let's say A. So you are visiting the first row first. So first value will be always 0, current row number, so that is constant. And what is changing? The column number. So you are going from 0 all the way up to right, or rather this column number goes from left all the way up to right. So you have to put you have to initialize your variables this way, and once you reach the rightmost right, so this value is equal to right, you change the direction. So now you are going down. So your column is fixed now when you are iterating these elements. 1, 2, 3, 4, all of them are in the same row, but their columns are increasing. Increasing from what to what? Increasing from left to right. So initially left, right are 0 and n-1 respectively. Then you go from down, you go from here, second row till bottom. And again in this fashion. So here right will be this starting value and left will be this 0. And again you are going up till second row. And again you go right. So there are four traversals in one loop. You can think of it as one loop, one entire loop. So you go right, then bottom, then left, then right. And this forms one loop. So you will have one outer loop where you are repeating these things: left to right, top to bottom, right to left, and down to up. And again after the end of this loop you change everything. So now left, you reach here again. So again you are starting movement in the right direction, but from 1 instead of 0. So instead of column number 0, so now you're at the end of this loop, this outer loop, left should be incremented by 1, right should be decremented by 1, because you will not go all the way up to last column. Similarly, when coming down, you will not go all the way up to last row, but rather one less. So down should be minus minus, and again while going up you would stop one row below. So up should be plus plus. So if you do these things carefully, you can visit all the elements. And what will be the time complexity? Of course you have to visit everything, and you are not going to any cell twice. So that should be O of mn, where m is the number of rows and n is the number of columns. So this is the time complexity. And space, you are not using any extra space other than these few variables, left, right, up, down. So O of 1. And this is lead code problem number 54. Now let's see the fourth problem. It's called median of two sorted arrays. It's also a very popular problem. So you are given two arrays which are already sorted. You have to find the median. So by median we mean a number that divides a data set into exactly two parts. So in this case we have 1, 2, 3, 3, 5. 1, 2, 3, 3, 5. So if you take this 3, any one of these 3, or rather in this case it's odd number, so there is a definite midpoint. So if you take this 3, there are two numbers less than it, two numbers greater than equal to this. So the median is 3. The median may not always be present. Let's say we had 1, 2, 3 and then we had 4, but this 5 was not there. So 1, 2, 3, 4. Then the median will be here, 2.5. So in the case of even number, we will have two mid values, so take the average of that. In the case of odd number of values, take the middle one. So if you add all the elements and then find the median, then that will be m plus n time. If this has m elements and n elements, these are already sorted, so you can merge them using merge step of the merge sort, and that will take m plus n time. And then you just go to the middle one or two middle and take the average. But you are not using the fact that these are already sorted, so you can do it in log of m plus n time rather. The best solution would be that. So log of the number of elements. So that will come from the fact that you have, let's say, two arrays which are already sorted. So you compare their middle values and depending on that, now these are the 4 halves that are formed. So every time you will remove one of these 4 values. So if initially we had, let's say, n, then next time it will be 3n by 4, roughly, not exactly, and then again 3 by 4 whole square n. So it's decreasing by a factor of 3 by 4. So you can think of it as roughly logarithmic time. So you can see the details on LeetCode page for LeetCode problem number 4. Now let's see the next problem. It's called frog jump. So we have a few stones in this case. So these are the stones, and this is at position 0. And this is the first stone, second stone. So these are the stones. And these are denoting the indices of stones. So here you see 0, 1. So these are contiguous. There is a gap of just 1 unit. Here you have 1, 3. So there is a gap of 2 steps. So this difference denotes steps. So a frog has to go from first stone till last. And you have to return true or false whether it's possible or not. Because there is some rule to how many steps a frog can take. So initially the frog will always take 1 step. So if it's 0 and 2, then that's not possible. So it has to be 1. So it goes from 0 to 1 step. So at any point of time, if the previous number of steps was s, then the next jump. So previous jump was of s steps, then the next jump can be either s minus 1, s, or s plus 1. So these are the 3 possibilities depending on the previous jump size. So it cannot be arbitrary. So you have to return whether it's possible or not. So here the frog will make a jump of 1 unit. Then it will reach at 1 here. Now it's a gap of 2. Then again a gap of 2. Then a gap of 1. Then 6 to 8 there is a gap of 2, 4 and 5. So I have written the step sizes, the jump sizes required. So now the next jump should be either 0. 0 does not make any sense. It will keep on having here only. So 1, 0 and 2. So here is a gap of 2. So it can jump by 2 steps. So previous jump is 2. So now the next jump can be either 1, 2 or 3. So either it can come here. 1 is also allowed and 2 is also allowed. Sorry, 2 is allowed and 3 is also allowed. So it can come here or straight away here. So out of these, only 1 it has to take. So let's say it comes here at this 2. Then it can again take 1 step and then 2 steps. But if it reaches here by 2 steps, then it cannot reach here because it can take only 1, 2 or 3. But here it's a gap of 4. So if it takes a jump of 3, then next can be 2, 3 or 4. But with 2 it will reach here. So again it cannot reach there. So there is something wrong. Let's say we take a jump of 2 here. And then we take a jump of 3 here. And take a jump of 4 here. And then a jump of 5. So this should be the case, not this one. So in this case it's possible. So it's true. If it was not possible, let's say it was 6 steps behind or anywhere within, then we would return false. So this is LeetCode problem number 403. And if you use the naive approach, then I would give a rough estimate, like at every point you have 3 options. Either take step minus 1 step or step plus 1. So you will have to try all the 3 possibilities and the solution may explode to 3 raised to the power n or exponential. So you will have to use some sort of dynamic programming to avoid calculating again for a step where you have reached with certain steps. So try to solve that and try to use dynamic programming there. So let's see the next problem. It's called add 2 numbers and the numbers are stored in the singly linked list fashion and the numbers are stored in reverse order. So this is 243, but it denotes 342. So 342. And the next one is 465. So what happens if you add them? 708. So this 708 denotes 807. So if the numbers are in normal addition, we add from right to left, least significant bit, least significant digit to most significant digit. In this case, it's reverse. So you can start from left to right. That's for ease of usage, since in the linked list we have singly linked list, we have access to the head, and we are allowed to go from left to right. So you add 5 and 2, the value is 7. There is no carry forward, so carry forward is 0. Then you go next in both the lists, and you reach here. 6, 4 is 10, so you add 0, and 1 is carry forward, and then 4, 3, 7, and 1, 8. So this may not be always equal. It may have, let's say, 5 here. So it will denote this one. So when this ends, so you have to return a new list. You can just add the carry values and just process this list, because the other list has ended. So what will be time complexity? It will be the bigger of the lists. So if it is m and this is n, then the time will be the longer one, max of m and n. And it's LeetCode problem number 2. Let's see the next one. It's called trapping of rainwater. So we have a few skyscrapers and there are some gaps. So these are denoting the heights of those buildings. So 0, 1, again 0, and then 2, 1, 0, 1, 3, and these light colored are the waters. So water can be trapped when it's enclosed by buildings on both the sides. So this is LeetCode number 42. So this is a very popular problem and it comes under hard category. So here you will have to keep track of what is the left maximum, like till this point left, this is the current left. So when you are going from left to right, this is the left index, and max till now is 0. So if left is less than left max, then only water can be trapped. If left itself is the taller building, water cannot be trapped above it. So here water is not trapped, left max is 0 and left is also 0. Then you come here, then this value is more than max, which was 0. So left max becomes 1 and left is also 1. So again no water here at this point. When we come here, this value is 0, but left max is 1. So there is a difference of 1 in the height. So 1 unit of water can be trapped. Similarly, you have to keep track of the right max also. Maybe this is less than left max, but there is no building to the right. So again, no water can be stored. So you have to keep track of right max, left max, and you can do it in one iteration. So it can be a linear time, and space would be just constant O of 1. So now let's see the next problem. It's called number of islands. Again, this is a problem being repeated. I would have already covered in either Microsoft or Amazon interviews, top 10 interviews. So here we have 4-way connectivity, vertical and horizontal. So if you see, this is one island, again one island, and one island is here. So these are not connected, diagonal connectivity is not there. So 1 denotes land, 0 denotes water. So you have to return this number of islands, and it can be done by a simple graph traversal, and that will take time equal to number of cells, number of rows and columns, number of nodes. So this is LeetCode problem number 200. So let's see the next problem. It's called maximum subarray. So this is the initial array which will have positive and negative numbers. If all numbers are non-negative, then the maximum subarray would be definitely the entire array. But we have negative numbers also. So maybe this to this is, let's say, 10. Then we have minus 5. And let's say this part is sum from of this subarray is 6. So if you add everything, you have a net plus 1. So it will be 11. But let's say this was 4. This subarray and this subarray is 10, and this subarray is minus 5. So you will not add all of these. You will pick this one. So that's how you have to find the maximum subarray, and this is lead code number 53. So let's see the next problem. It's called find the median from data stream. So you have a running stream of data, and you have to find the running median. So you have to design the class median finder, the constructor, and you should have a mechanism to add a new number from the stream and then find the current median. So let's say median finder, it initializes the constructor, then we add 1, then we add 2, and then we find median. So till this point we have 1 and 2, so the median is 1.5. Then again we add 3 and again call median. So 1, 2, 3, so the median is now 2. So you can use a heap here to keep track of the running median. So I will not go into the detail of the solution, but you can think on that line. And this is lead code problem number 295. So I hope these 10 problems would give you some enough starting point and enough practice to get started if you are practicing for Apple interviews. So please subscribe the channel, and thanks for watching.